Okay, next problem and last one for the night. Let's see, we've got problem 2 tax 64. So this is another kind of thought one, so there's not too much math involved here. I mean, maybe a little bit, but it's more thinking about it. So examine each diagram below. Identify the error in each diagram. So let's go ahead and look at this first one here. So we've got a triangle, and they're saying that this side is 3 meters, this side is 5 meters, and this side is 9 meters. So take a second and think about that. Take a look at it, and you can pause the video or whatever. But take a look and think about whether or not that looks correct. And so once you've thought about it here for a second, let's look at what kind of identities we know, or what kind of rules about triangles we know. So one of the most fundamental ones is that triangle inequality, right? Do you remember what that is? So what that says is that if you take any two sides of a triangle and add them together, they must be longer or bigger than that third side, right? So they clearly didn't mention that none of these things are drawn to scale. But let's take 3 and 5 and add that together. We get 8, right? 3 and 5 is 8. If you draw this thing to scale, it's not even a triangle, because you can't have two sides that they're not bigger than the third side, right? Because if you looked at this triangle and you tried to like make this side 3 and 5, like it wouldn't even be the full length of this one. It wouldn't even touch. So this can't be a triangle because of the triangle inequality. It does not fulfill the triangle inequality. 9 plus 3 is 12, so that's bigger than 5. 9 plus 5 is 14, which is bigger than 3. But 3 plus 5 is 8, which is not bigger than 9. So not a triangle. Let's see what they say. Compare the length of the longest side with the sum of the two shorter sides. Yep. So they're kind of hinting at that triangle inequality. So remember the triangle inequality. That's a really big concept that you can use to tell whether triangles are real or whether or not you've got your measurements wrong. But also it's just something that's true about all valid triangles, all real-world triangles. So it's pretty fundamental math thing. So remember that thing. It's called the triangle inequality. And actually, you can probably even Google it. Triangle inequality. Because it's a very cool. Yep, here you go. It's got a whole Wikipedia page all on it. You could probably even Google it and read about YouTube videos about it, but it's just one of those physical things, right? Here they show you x and y, and if x and y are so close to z, it just becomes a straight line, right? So go ahead and read about that. It's a very cool, very simple concept, but it's also very powerful. So that one, triangle inequality, not valid. This one, well, let's do a quick check of the triangle inequality since I just spent so much time talking about it. 5 plus 14 is 19. That's bigger than 12. We're good there. 14 plus 12, definitely bigger than 5. Good there. That's 26. 12 plus 5, 17. Bigger than 14. Cool. Fulfills the triangle inequality. However, they're giving us a hint. They're showing this little thing. They're showing that this is a right angle. So, if it's a right angle, we can use the Pythagorean theorem, because that means that this side right here should be the same as, so 5 squared plus 12 squared better equal 14 squared. Let's go ahead and see if that's true. Let me get rid of all that stuff. Let's go here and see if, so 5 squared is 25, right? 12 squared is 144, right? Equals 14 squared. I don't exactly remember what 14 squared is, but I think it's 196. Let's go ahead and check. Let's see, 14 times 14 equals 196. Good, okay. So, is that equal? Well, let's see, 25 plus 144, that's going to be 169. No, it's not. It's not correct. So that does not fulfill the Pythagorean theorem. This one of these sides is not correct. Let's see what they say. Test the side lengths with the Pythagorean theorem. Boom. Wrong. Not a valid triangle. Okay. So, we got that one. Okay, so Pythagorean theorem, very important also. It's actually, yeah, there's only a couple things when it comes to trigonometry and geometry that are super important. Triangle inequality is one. Knowing the internal angles of a triangle. Some congruence rules would be good. But the rest of it's like Pythagorean theorem. I mean, it's all basics, right? Like this is stuff that for geometry lasts you for the rest of your life. If you can remember these rules, they're just going to come up over and over again, and there's not too much more. I mean, if you know some of these fundamentals, you can come up with a lot of the more advanced stuff. All right, so let's look at this one. Okay, here we go. Boom. Looks like 7 inches on this side, 7 inches on this side. So these two sides are equal. So what kind of triangle is this? This is an isosceles triangle, which means this side is equal to this side. This angle must be equal to this angle. So we can kind of fill that in then. So let me go ahead and draw that real quick here. Shapes. How come it displayed my shapes funny? Let's try that again. Shapes. Show me my triangle. There we go. Alright, and let's draw a triangle here. Close enough. Maybe a little bit more like that. Alright, and then let me write my sides in here. So this is 65. 65. Okay, and this is 7. And this is 7. This one is 55. Boink. And so since this side is equal to this side, we know that this is an isosceles triangle, so this angle must be equal to this angle. So that is 65. Boom. Alright, we don't really know what this side is. We could figure it out, and you'll learn how to do that when they start getting into sine and cosine and tangent. There's some triangles are like really cool just in the world. They're also very useful for the Navy. I've learned a lot about how we use math like this in the Navy, and I can tell you about it when I get back. It's not secret or anything, it's just kind of a little bit technical, but it's how we do geolocation, so it's how we locate things on the globe, it's how we find ships and find people who are missing, it's how satellites do a lot of their work, but it's pretty cool stuff. So if you ever want to work in any of those areas or learn about those areas, that's basic. They're using very basic math, but they use it in a complicated, very smart ways, but it's this same kind of trigonometric math with sine, cosine, tangent, triangle inequalities, isosceles triangles. It's all just math, but it's really cool how they do it. Anyways, so let's see. So these two sides are equal. We could figure out this side, but we don't care at the moment because what we've got is we've got a couple things to check. Well, at least one thing. We know that the angles in a triangle are supposed to add up to 180. Let's see if these add up to 180. I'm thinking they don't. Let's see here. 65 plus 65 plus 55 equals 185. We got an extra 5 degrees in here somewhere. Something's wrong. Something's wrong. That's not correct. So, angles in a triangle should add up to 180 degrees. It's pretty well known, kind of fundamental, and they failed. Alright, but hopefully you're kind of catching on. I don't know. I think it's really cool to learn some of this kind of stuff, and it's really interesting how these fundamental concepts just keep coming up, even as, you know, I'm almost 40 years old, right? And these things are just, like, you don't have to even go that much farther past this kind of math. You can, but if you know this kind of math really well, this will get you really far in life, just in all different areas. Whether it's the Navy, the military, or computers, or science of any kind, it gets you pretty far just having a really good grasp of high school math. So, in any case, I think we're all done for tonight, and hopefully it wasn't too hard. A lot of it was just thought exercises, but hopefully you're getting to be able to think about these things a little bit better, Jonte. All right, well, I'll let you get back to it, and you have a great night, and I miss you guys, and I look forward to talking with you and catching up with you all soon. Okay, bye-bye.